This is the notes for section 9 for fitting exponential models to data. If you haven't done so already, make sure you pause the video and read the section before continuing on. So what we're going to do is we're going to look at in this section how you can fit a exponential equation as a model to a set of data. And the first thing I want to do is looking at finding exponential models for data that we believe are exponential. Okay. There's two different ways that we're going to look at doing this. The first is kind of without your calculator's resources, and the second is with it. So in this first method, we're going to follow kind of these four steps. We'll start with the general equation y equals ab to the x, and when we do that, really what we need to go from that general equation to a specific equation, what I really need to do is I need to figure out, well, what is a and what is b. So I need to find those two values in order to get a specific equation. Well, in order to do that, we're going to start by using two ordered pairs from the data that we have. Okay, and anytime we're going to do this, we're going to have a set of ordered pairs that is the data set that we're working with. Okay, when we do that, we're going to get two equations in terms of a and b. Now, if one of your ordered pairs has the x, or the independent variable, as being 0, that's really nice, because then you automatically will know the starting value, because when you put x equals 0 in, okay, that leaves you with your starting values. So that's pretty nice. We'll take a look at that here in this next example. Okay, the third thing that we're going to do is we'll solve that system for a and b, and then finally we'll take what we get for a and b and substitute it back into the general equation here so we can get a specific equation. So let's look at example 1 here. We're going to use the method that we just described above to come up with our answer for this. It says the table below gives the percentage of sunlight present at various depths in a part of an ocean. Find the exponential model to fit the data using the initial condition as 1 and one other order point in the table. Okay, so to begin with, I'm just going to say we're doing this. We have y equals ab to the x, and we're told that we're looking for an exponential model, so we know it's got to look like that. So to get a specific one, I'm looking for a and b. To begin with, I'm going to use two ordered pairs. I'm going to use the first ordered pair of 0, 100. And then I need to use one other ordered pair as well. A lot of times I'll just pick the last one, because then it's going to represent that whole set of data sometimes a little bit better, depending on how closely that the data matches the exponential model. So I'm going to pick those two ordered pairs. To begin with, if I put 0 in for x and 100 in for y, here's where I was explaining how this will automatically give us our a value. If I do that, okay, I get b to the 0. Well, I know no matter what, b to the 0 is equal to 1. So really that's just saying 100 is equal to a times 1, which is just a would have to be 100. Okay. Well, since I already know what a is just by using one of the ordered pairs, I'm going to plug that in here and use my second ordered pair to find b. So I'm going to say y equals 100 b to the x. And now let's plug in my other ordered pair. So I have 0.001 is equal to 100 times b raised to the 50th power. So what I'm going to do then is I'm going to solve this by dividing by 100 on both sides. Okay, so I have, and I'm just going to leave that like this and do all my calculation at the end here, is equal to b to the 50th power. And then to find b, I'm going to take the 50th root of that, and that will give me my value for b. So now is when I'm going to go to my calculator to find my value of b. So when I put that in my calculator, so over here for b I'm going to put 0.794. Therefore, my equation that I'm looking for would be y equals 100, that was our a value, times 0.794 raised to the x power. This would represent an exponential model for the data that we have there. Okay, the second method that we can use for finding an exponential model is with your CAS calculator. And I've got kind of a 7 steps that we're going to follow, and that looks more complicated than it actually is. We've actually used the same process when we were doing both linear regressions and when we were doing quadratic regressions. But basically we're going to start out with a list and spreadsheet. We're going to label the two columns. That's important, that labeling of the two columns. So if you don't do that, it's going to be kind of impossible for us to make those next steps. So make sure that you label the two columns, and then you want to go ahead and enter all of that data in those first two columns. Once you've done that, then we're going to do a data and statistics, where we add a data and statistics, and then we're going to have to add the appropriate thing on the x and the y axis. And then we go to Menu, Analyze, Regression, Show Exponential. So here's where it's different. We've used Show Linear Regression, we used Show Quadratic Regression, now we're going to use Show an Exponential Regression. Okay? The function that will show up will be the exponential model then for that data. The closer the points are to the curve, the better that data fits the curve. Okay? So what I'd like to do is I'd like to walk through this example too using the method that I just described above, using your CAS, so you can kind of see how it goes. As I go ahead and do this, make sure you have your CAS out and you're doing it with me. It's going to work much better if you're kind of doing it along as I go along here, so you can kind of follow along. It says the amount of decaying substance that remains after d days is shown in the table below. Find an exponential model to the data and determine if the exponential model is appropriate. And then once we have that model, use the model to estimate the amount of substance remaining after 20 days. Okay? So let's go ahead and do that. So the first thing we need to do is we come over to our calculator, and probably best to start with a new document when you do this. And then once you started with the new document, then you want to add a spreadsheet, so list and spreadsheet. When you do that, it will bring up this, and this is where we're going to enter our data. Make sure you put titles on each of these. So you might want to pause the video at this time and then go ahead and enter that data from your notes into those first two columns. So once you've entered that data, and I labeled mine with D and A on top. Once you've entered that D for days and A for the amount of substance that's left, once you've entered that, okay, in your spreadsheet, and you got to have those labels, then we can go to that next step, and that next step is to add a data and statistics. So you're going to go to your home key again. Okay, so you're at your home screen. Now you want to pick data and statistics, which is this one right here. Click on it, and we will add a screen like this. Now you'll notice that you've got the points all over the place like we've had before. Now we've got to click to add the variables. So if I come over here, and if I get over the top of it, we can highlight that, and we want to select, we want on this axis, we want the A, the amount of substance that's left, because that's dependent upon the number of days. And then we got to come down here, and remember it won't appear until you get over the top of it. Once you do that, you want to select D for the number of days. Okay, and it will bring that data out. Now this is where we can look at our scatter plot, and we can look and see, is this modeling an exponential function? It certainly appears to be doing that. Okay, so since it appears to be modeling an exponential equation, we want to see if we can get that regression. So that's where we're going to go to Menu, and I'm going to actually show this the way you're going to see it. You're going to go to Menu, and then you want to go to Analyze, and then you want to go to Regression, and we want to look for show exponential. Okay? When you do that, it brings in that exponential equation that is this right here is the model equation for your data. So your A value is 998.22 and your B value is 0.801805. Okay? So that's what you have for your model. So that's part A of that question. Now to do part B, where it says to find the amount that's remaining after 20 days, all I'm going to do is I'm going to take x out and replace it with 20. So in my calculator, I'm going to put this in and raise it to the 20th power. Okay? You want to do that on your calculator, and we can find what that answer would be. So what I did is I just defined f1 of x as being that function. So now if I want to find f1 of anything, I can say f1 of, in this case, 20. And I can let the calculator do the work on that. And you'll see that it's about 12.04 if I round that off. So that would be the value of the amount A after 20 days. So A would be, and let's just round it to the nearest gram. So after 20 days, A would be approximately equal to 12 grams of substance. Okay?